Okay, we're going to have a very quick look at lithium rechargeable cells. These would be the cells or batteries that you might find in mobile phones or laptops. Very common indeed, and one of the reasons they're so popular is because lithium, being such a light metal, is very energy dense when you might measure energy density in amount of energy per gram of battery. So we're going to have a look at the reactions in one of these lithium rechargeable cells, and I'm going to use this little diagram to help us. So what we've got here is the whole cell, and the blue bar is to represent the anode. All right, so let's label that anode, and then the yellow bar is the cathode, and this is our membrane again. So that's our membrane. Now at the anode, the anode consists of a graphite electrode coated with lithium. Okay, so we've got lithium metal all over this anode, and the cathode consists also of a graphite electrode, and that is coated with cobalt oxide. Cobalt oxide, like so. Okay, so the reaction that happens at the anode when you're using it, i.e. discharge, is that lithium, let's change colour to, let's have a bit of purple, shall we? So the reaction that happens here is our lithium solid, right, it gets ionized into a lithium ion and releases an electron. Okay, now the electron can't get through the membrane. The membrane only lets lithium ions through. Okay, so the electron has to come up here, and it's going to do some work in some sort of appliance like a phone, and it's going to end up on the other electrode like so. And the lithium ion, so the lithium ion comes through the membrane, carries all the way through, and gets all the way to the cathode. And the reaction that happens at the cathode is the lithium ion reacts with the cobalt oxide and the electron that has made its way around the circuit, and that makes some lithium cobalt oxide, some lithium cobalt oxide, like so. Right, in the process the cobalt has changed oxidation state, so you see the oxidation state of cobalt in cobalt oxide is going to be +4, but the oxidation number of cobalt in lithium cobalt oxide is only +3. So you can see this electron that was with the lithium atom and has gone around the circuit has actually jumped onto the cobalt ion there in lithium cobalt oxide. So that's the process that goes on. Let's give you some electrode potentials. So at the anode we've got about -3 volts for the reduction reaction. We've got an oxidation reaction going on here, but electron potential is always given for the reduction reaction. And at the cathode we've got about +0.6 volts for this reduction reaction. And while we're at it, let's just make sure that we know what's going on at the anode. Right, so at the anode, this is oxidation. Right, and in a discharging cell, oxidation happens at the negative electrode. This is the negative electrode. So, and the negative electrode is the anode in discharging cells. Whereas in electrolysis it's the opposite, obviously. Whereas at the cathode, right, so here's the cathode, at the cathode this is a reduction reaction. This is a reduction reaction, and in discharging cells that makes it the positive electrode. Okay, so last thing to do is just to work out the EMF of the cell. Right, so the E cell is the, you might remember, is E of the reduction minus E oxidation. Okay, so we've got the reduction reaction is at the cathode here, and that is plus 0.6, and then minus our oxidation, well, the electron potential of the anode, or the oxidation reaction, and that is minus 3 volts. So altogether we've got 3.6 volts, which is quite a nice little voltage from a cell, and that together with the fact that lithium is so light is the reasons why lithium rechargeable cells are so popular. Just before we finish, let's do the last thing, which is recharging. So I'll quickly mention recharging. When you plug it in to the power supply, basically the power of the mains makes the electrons go around in the opposite direction to the way that they want to go. Right, so they're going to leave the lithium cobalt oxide, and that was going to make the lithium ion travel back from whence it came and recoat the anode in lithium metal, so that then you can use it again and go through the whole discharge process again the next day after you've recharged your battery. Okay, hopefully that's been clear, and that's it for lithium rechargeable cells.